Okay, so this part we will mainly discuss about ethics in data. As I told you, like there are some sensitive data and it should not be released to the wide public or should not be leaked, right? So therefore, this brings us to ethics in data, right? So very theoretical topic. This session, like this 20-30 minute session, will be very theoretical. But of course, you will get to know some ideas about this. Okay. We'll also discuss a very theoretical aspect of big data which will be coming in your maybe in your semester 3. Okay, you will be learning at a course in semester 3, big data analytics. Okay, so what is big data and how we can handle those big data, right? So coming to ethics. Okay, so data ethics, you can see these are the principles behind how your organization gather, protect and use data, right? So in a world where data is most valuable and ubiquitous than ever, data ethics issues are more pressing. Okay, because whenever you go to any malls or any public places, they ask your phone number or names like that. And if you give, so these are the third party apps which can collect your data and later can contact you, or those third party apps might not be safe and might risk in your privacy loss. Okay, and sometimes even fraudulent activities might take place. So therefore, data ethics matter. Okay, so you can see these are many different cases which I have collected. Like in 2018, hackers they injected a malicious code in British Airways website and which diverted traffic to a fraudulent replica site. Okay, and customers unknowingly gave their private information to fraudsters, including their login details, their payment card information because they have to book a flight. Okay, and travel booking information also. In 2018, Apple introduced its credit card to customers like Apple credit card, but allegations of an algorithm with gender bias emerged. Okay, so these are the pressing issues which showed that data only is not meant for analytics, is also meant for preservation and proper storage. Okay, so you can see like popular tech executives like Steve Wozniak, like famous technologist and co-founder of Apple. He told that described receiving exponentially higher credit limits than their wives, okay, with whom they shared assets, right? So these are some of the pressing issues you can see in 2021 also. Privacy of over 553 million Facebook users were compromised with their data, which was posted on an open hackers forum, and one of the largest data breaches of all time. Okay, so this incident raised issues or concerns about how organizations are storing data and how their personal informations are getting secured, and whether they should be allowed access to such data at first place, right? So these are the small snapshot of the breaches in your digital security. Fine. You can see, regardless of how low tech you may be, the importance of that data ethics cannot be ignored. Okay. So the consent of your personal information or selling of your personal information becomes an important topic, and obviously it affects your parts of life. So you can see this is the personal data and Instagram here. You can see the amount of based on the privacy levels in the app store. Okay, it shows how much amount of information is being shared. So you can see the companies over here, how many, which company is using how much amount of data. So in the dark about data, so while most people are broadly aware that companies collect data on them, so companies collect data on them, they are surprisingly uninformed about specific types of data they give up when they go online. Okay, when you go online, how much amount of data you are giving about yourself to the company, to the particular company. Okay, so you can see when you are in this social network friends list, you are so percentage of people who realize they are sharing their data with. Okay, so 27% you can see with social network friends list, or if you share your location also, 25% is almost data is gone about yourself. 23% about your web search. When you do a web search, I mean, if you're doing a web search on maybe football or some sports event, most likely they think of, yeah, you must be this, and you suddenly get started getting different notifications in different YouTube or something like that, right? So 14% on web surfing history. Okay, and where is your IP address about? Like if your IP address is somewhere in India and you are searching on other items, they clearly monitor that. Which items are you purchasing from which country and all that, right? So therefore, you see when you use some kind of blocker, like then some websites open, okay, but some websites are banned in India, right? Because of conflicts, so they you cannot open them. Anyway, so you can see this is the MeitY web page, and here you can actually get the Digital Personal Protection Act 2023. Okay, so you can read more about this act, how I mean you can store your data and how you can be digitally safe. Okay, so this is an act which I think everyone should know about. Okay, fine. So this is all about ethics. Just a snapshot of ethics, data ethics to you. Now, a little bit of snapshot about big data. I mean, you can learn more about big data, Hadoop, and all those things in your third semester. But this is a very basic overview what it is about. Big data. So how big is big? Okay. So there is no precise definition of how big is big. So when we can no longer deal with the data using traditional methods, that's when we realize that our data is big and we are undergoing through the process of big data handling. Okay. So when your traditional computer gives up by analyzing the data, then you realize that your data is big. Okay. You are facing big data. Okay. So you can see, can we process or store data on a single computer if we are having big data? Okay. If we cannot, then we are probably dealing with big data. Okay. Then we are probably dealing with big data, right? So you need to have new methods other than the traditional methods. You need to have new methods other than the traditional methods in order to able to handle and process the big data. Okay. So this brings down to the, I mean, 5 V's in big data. We will see. Let us hear one line from the executive chairman of Google also. Like you can see, from the dawn of civilization until 2003, humankind have generated around 5 exabytes of data. Now we produce 5 exabytes of data every 2 days, and the pace is accelerating. Okay, so now you must have heard the news that some countries, they developed a strategy in which they downloaded the whole YouTube. They downloaded the whole YouTube data, some high quality of data, high amount of data, but they downloaded within few hours that data. Okay, and they stored also. So even though you don't have internet, you can still browse and do those things. So which is quite interesting. So volume. So all aspects of modern life are digitized. You can see Facebook here, YouTube. I don't remember what is TW. I don't. Telegram web, maybe Telegram. Twitter, yeah. Good. Twitter. So the WhatsApp, and this is Instagram, right? So you can see that. And velocity, at what rate your I mean data is coming to. So you can see this is multimedia. Flickr is there, so growing at an amazing rate. You can see Instagram, more than 1 billion photographs. YouTube, 100 hours of new videos uploaded to the site every minute. Over 1 billion unique users each month. So a very nice way to gather data and put data also. Biological data also, which is quite interesting, that you have 3 gigabases, 3 into 10 to the power 9 base pairs of human genome, which can be sequenced in few days. So I don't know much about it, but I have understood some part of it, and that's how they were finding vaccination for COVID. Which sequence can actually pair up with our sequence and can actually, remove that, what you call that, virus genome, right? So therefore, what kind of sequence they can have? Turns out that they have to perform billions of iterations and billions of permutations. So therefore, they needed a supercomputer or powerful computer to do those kind of genomic analysis and come back to and find a vaccine, right? So therefore, I mean, now biology is not more relevant to the, sorry, not much only chemical oriented, but it has become a computationally oriented field, like which gave rise to computational biology, okay, and bioinformatics, right? So why, okay, we are not Facebook or Instagram or Google, like then why we need to worry about this? We need to worry because some of our data is being taken and we don't know that it is taken. So that's the logic behind this. So anyway, There are variety of data like RDMS, Relational Database Management System, where you have structured data with well-defined fields. Okay, so now the data sets we are getting, the data we are getting through multiple fields are unstructured data, right? Maybe suddenly you will see on Reddit or something many different websites data is not properly pasted. Okay, so these are not structured data. So again, you have to go, if you want to collect this data, you have to go through pre-processing, structuring your data properly. So unstructured data, data coming in lot of different formats, images, audio, video, likes, etc. Likes also, like number of likes, thumbs up, like different reactions of liking. So many things are there, and that gives a challenge of unstructuredness in your data. Okay, veracity, like you can see sensor data from different fields, biological data, verification is hard due to its scale. I mean, lot of scale is there. Heavy big data is present. Most of them faced with internal inconsistency, okay, which needs probably sometimes manual verification, which leads to more challenges. The moment manual verification comes into picture, it becomes hard also. Anyway, this is the value. So how you can monetize your big data? Okay, identify problems where returns are higher than investment. In that way, you can monetize big data. Okay, so you can see the recommendation systems, sentiment analysis. Now using sentiment analysis, they can predict which movie is going to be a hit or which movie is going to surpass another movie. So these are, you are trying to understand sentiment of people over the social media. So some of the students are already working on their capstone project, like understanding sentiment analysis. Okay, so understanding sentiment analysis, based on that, you can see what the population is worried about. Is the population talking about a movie, or is the population talking about maybe some other real life situation that has happened on the news? So based on that, you can identify whether the people are more aggressive on the movie aspect or more aggressive about some other real life situations. So that's how sentiment analysis works. And smart cities also, like you can think of. Anyway, uh, visualization also is a big challenge for your big data. I mean, if you have data which you can handle in a computer or laptop, you can just visualize using x-axis, y-axis, scatter plot, line plot. We will understand them in data visualization module. But how to understand or visualize big data? That's brings that brings challenges to understand how to create novel methods to visualize those big data. Okay, you cannot maybe visualize just by using a line plot or a histogram. Maybe some new novel methods are needed. So you can see no one answer will work for it. So old visualization techniques might fail, okay, which can limit our insights. Some insights we might miss if you use just that old traditional data, right? So new generation methods are needed. So this is uh, some good book which I suggest, Big Data for Dummies. So I mean, I it always gives the title as dummies, but the inside material is always high quality materials. So Big Data for Dummies, I'll try to send a PDF to this. So a distributed computing approach is needed actually. So it's not about how much power a single computer has, but rather how we can use multiple computers to split the data up and process everything using the multiple computers. So that is where the paradigm of parallel computing began. Okay, how you can use parallel computing or GPU computing. Okay, some students were mentioning about CUDA, right? That's like a parallel computing strategy, right? So popular paradigm is MapReduce also. In if you want to handle big data, you can use MapReduce and Hadoop. Okay, these are open source platform. Hadoop is an open source platform. Try to Google it. Try to Google Hadoop and try to understand what it does. Okay, so we'll manage kind of cluster resources where files are stored and provide fault tolerance and reliability. So that's one of the features of Hadoop. So try to ingest data coming in using Apache Spark. Okay, so you can use Apache Spark, Apache Fume. So these all things might be you will hear in third semester in big data course. Okay, fine. So, okay, so this is all about the big data, just an overview of big data and ethics in your data, right? So, so it's good. I hope you will understand more about this in your upcoming semesters. Okay.